So this is an example of balancing an aqueous redox reaction in acidic solution. And so first of all, remember that all the spectator ions have been canceled out. We're only interested in chromium 3 plus and the bismuthate ion going to dichromate and the bismuth 3 ion. We have cut out anything else that wasn't actually participating in the reaction. Except for a few things. Remember that this is aqueous, and so this is really water that's also available that we'll be using. And it's acidic, so that also means there is some hydrogen ions, H plus ions, that we can use to balance this. So the first step in this whole process is to take this and split it up into two half reactions, the oxidation and reduction. And we don't have to know which one is which just yet. We're just going to split them up for right now. So we're going to say the chromium 3 plus, that's going to be paired up with the dichromate ion, and the bismuthate ion, BiO3, is going to be paired up with Bi3 plus. Now, step 2 says to balance everything except oxygen and hydrogen. And sometimes that you don't have to do anything, but in this case there are two chromiums on the right in the dichromate ion. There's only one on the left. And so I'm going to put a 2 in front of this chromium 3 plus right here. Now, the next step is to balance the oxygens, and how we do that is by adding waters. So if I look at the first half reaction, I need to add 7 waters to that one in order to make this work out. And in the second reaction, I need to add 3 waters to make the oxygens balance out. All right, so the next step is to balance the hydrogens. Now, there weren't any hydrogens to begin with, but now we've added some hydrogens. So now 7 times 2 is 14. The other side needs 14 hydrogen ions. And in the second reaction, there are 6 hydrogens on the right. I need to add 6 hydrogen ions on the left. All right. The next step in the process is to balance out the charges. And so you have to look at each reaction. What we're doing is we're looking at the superscript charges here. We're saying, okay, well, the chromium, it's got a +3 charge. There are 2 of them. 2 times +3 is a +6. The water doesn't have any charge, so that left side is a +6. There's one dichromate at a -2, and there's 14 positives. That is a +12. And so you look at the more positive side. If you're using this method, the more positive side is +12. We want it to get to +6. So how do we get to +6? Well, they're 6 away from each other, so I add 6 electrons to this side. If I add 6 electrons, that gets me to +6, which is what the other side matches. Now, the second one, I have a +6 from 6 H pluses, and I have a -1, so that's a +5. The other side, only the bismuth has a charge, it's +3. I need to add electrons to the more positive side. +5 to +3 is a difference of 2, so I need to add 2 electrons to that side. All right, the next step is to get the number of electrons gained equal to the number of electrons lost. And before we do that, I want to point out one quick thing. We have just discovered if you put reaction, well, not we just discovered now, but if you write electrons on the product side, the 6 electrons in the first one, that is indicative that it's the oxidation half reaction. And if you write electrons on the reactant side, that's indicative that it's the reduction half reaction. So that's one way that you can determine that. All right, so the next step in the process is to multiply both equations by some number, each is different number, in order to get the number of electrons gained and lost the same. Well, what's the first number that 2 and 6 have in common? It ends up being 6. The first one I don't need to really multiply by anything then. The second one, since there's 2 electrons, I need to multiply that one by 3. And then what we do is we combine this together. And so we start, the first, I'm going to draw my arrow here. The first reaction, I didn't have to do anything, so I'm just going to leave that alone. Not going to change anything there. So Cr2O7, 2 negative, plus 14 hydrogens. I'm not going to write the electrons down because those will cancel out. The second reaction, I tripled everything. So 6 times 3 is now really 18. I need 3 bismuthate ions, BiO3 with a negative charge. I also need 3 bismuths on the other side, bismuth 3 plus ions. And I need 9 waters now. And so the last step is to simplify the reaction or reduce the reaction down. What we mean by that is notice how there are 18 hydrogens over here and 14 on the other side. We really, in the end, used a net of 4. So I'm going to cross those out, and I'm just going to write 4 hydrogens down on this side. There's 7 waters on the left, 9 on the right. I'm going to cancel out those 7 and really write down 2 waters on the left. So what we really are left with, if we fill in the other pieces, which rarely, if ever, will cancel out at that last step. We get something that looks like this. 2 chromium-3 ions reacting with 4 hydrogen ions and 3 bismuthate ions to make the dichromy ion, 3 bismuth 3 plus ions, and 2 waters. Now, as a last check, you can sort of do something similar to what you're doing in one of the previous steps. If I check the charges, 2 times a plus 3 is a plus 6, 4 times a plus 1 is a plus 4, minus a 3. That gives me a plus 7. If I look at the other side, I have a negative 2 in the dichromate ion, and I have 3 positive 3s. 3 times plus 3 is a plus 9. There's no charges in the waters. Let me just put a plus sign in between that. If I add up a negative 2 and a plus 9, I get a plus 7. Notice how the charges on both sides match each other. So that's a pretty good indicator that this right here is the balanced redox reaction for the acidic aqueous reaction that's occurring here.